Friends, once again into VK Jain Sir ki MEP classes. In this particular module, I am discussing automation and automatic controls in illumination systems. I shall limit my discussion to whatever can be done in India because uh, you have to follow strictly National Building Code 2016 or modification thereof by 2025 or 26. You cannot construct a building in India unless it is uh, done, it is constructed as per National Building Code 16. So I will limit my discussion to this particular code. Friends, we shall be discussing two different lighting automation and lighting control. So first let us decide what is lighting automation. It refers to the use of technology to control and manage lighting systems automatically. This can involve anything from simple timer to sophisticated systems that respond to environmental changes or user preferences. The goal is to enhance convenience, energy efficiency, and overall comfort in various settings. Whereas the lighting control systems are sometimes referred to under the term smart lighting. Lighting control systems serve to provide the right amount of light where and when it is needed. And at its core, lighting automation relies on combination of hardware and software to manage lights. Basic systems may include timers or dimmers that allow users to set schedules or adjust brightness level. More advanced systems incorporate sensors such as an motion detector or ambient light sensors, which can automatically turn lights on or off based on occupancy or natural light availability. In addition, a smart lighting system can be controlled remotely via smartphones or tablets, allowing users to adjust settings from anywhere. This level of control not only enhances convenience but also contributes to energy saving. Friends, we are discussing automation and automatic controls. Both use sensors, timers, and network devices to manage light levels, occupancy, and time schedules, enhancing energy efficiency and user comfort. These systems automatically adjust brightness or turn light on or off based on real-time data, often integrated with smart applications or building management systems. Uh, the key component of automated lighting, we have sensors include occupancy motion sensors and photocells daylight sensors for ambient light level. Controller are the brain that processes sensor data and executes commands such as dimmers, timer, and centralized control panel. Then we have to use networking and control. System can be wired, e.g. DALI, DALI, or wireless, allowing control via smartphone applications, tablets, or voice assistants. Then are interfaces. Smart switches, touch panels, and remote application provide user-defined scenes. Scenes can be created. Friends, we'll discuss now key automatic control strategies. They are occupancy sensing. Light automatically turn off when a room is unoccupied. Daylight harvesting. Sensors dim electrical light when natural light is sufficient. So we are able to combine that with natural daylight. Scheduling. Time waste programming for lighting to turn on or off at specific times. Next is scene setting. Pre-program modes, that is meeting, relax, cooking, adjust multiple lights simultaneously. Circadian lighting automatically adjust color temperature and brightness to align with the human biological clock. The common applications are residential, smart homes, smart bulbs, smart switches controlled by apps or voice, that is things like Alexa. Commercial, office buildings, classrooms, and warehousing using digital lighting interface systems for efficiency. For outdoor, street lighting and parking lot automation for safety and energy saving. Friends, we shall be discussing benefit of lighting automation one by one. First benefit is energy efficiency. One of the most compelling benefits of lighting automation is its potential for energy saving. Automated systems can reduce energy consumption by ensuring that lights are only on when needed. For instance, motion sensors can turn off lights in unoccupied rooms, while daylight sensors can adjust indoor lighting based on amount of natural light available outside. In commercial setting, this can lead to substantial cost saving over time as businesses can lower their energy bills while also contributing to sustainability efforts. Additionally, many automated systems are designed to work with energy efficient lighting technologies such as LED bulbs, further enhancing their efficiency. By integrating smart controls with energy management system, businesses can monitor energy usage in real time, identifying patterns and making informed adjustments that can lead to even greater savings. Frank, the second benefit of enhanced automation system is enhanced convenience and comfort. Lighting automation brings a level of convenience that traditional lighting systems cannot match. Users can create personalized lighting scenes for different activities such as reading, watching movies, or entertaining guests. These scenes can be activated with a single command, simplifying the process of adjusting light to suit various moods or tasks. Moreover, automated system can be programmed to follow daily routines. For instance, lights can gradually brighten in the morning to stimulate a natural sunrise, helping to wake occupants gently. In the evening, the lights can dim to create a relaxing atmosphere, promoting a scene of calm. Some advanced systems even allow for remote control via smartphone applications, enabling users to adjust their lighting from anywhere, whether they are at home or away. This level of control not only enhances comfort but also allows for greater adaptability to changing needs throughout the day. The color can also be changed from morning to evening and season wise. Friends, the third benefit of automation system is increased security. Lighting automation can also enhance security in homes and businesses. Automated lighting system can be programmed to mimic occupancy by turning light on and off at random intervals, deterring potential intruders. Additionally, motion activated lights can illuminate pathways or entryways when someone approaches, providing both safety and peace of mind. Incorporating smart lighting into a broader security system can further enhance safety measures. For examples, light can be integrated with security cameras and alarms, creating a comprehensive security solution that responds to potential threats. Furthermore, some systems can send alerts to homeowners' smartphone if unusual activity is detected, allowing to allowing for immediate action. This integration not only helps protect property but also fosters a greater sense of security for occupants, knowing that they have a proactive defense against potential intrusion. Now, something about the history of evolution of controls in lighting design. Manual inputs were the first method through which we could control lighting, and to this day remain the most basic and widespread form of lighting control. Beginning with the humble light switch in the late 1800s and progressing to dimming switches from the 1950, manual form of lighting control continue to be often used in residential spaces. For example, dimming allows users to control the level of light beyond the simple on and off application capabilities of the light switch, which helps create different light scenes and save energy also. In the late 1990s, open protocol like DALI began to emerge, allowing the communication between individual components of lighting system. DALI and DALI 2 continues to serve an open standard for lighting, bringing the benefits of improvement, interoperability, and allowing lighting system to interact with the components from different manufacturers. For example, with a wide range of luminaires, lighting control companies can also provide different system functionalities on top of such standards. Friends, the word DALI is acronym for Digital Addressable Lighting Interface. DALI is a two-way open protocol, a digital internationally adapted for languages used to control lighting such as LED divers. DALI and DALI 2 is an open standard for lighting Selection of the luminaries is easy when specifying DALI 2. With DALI 2, the control devices are also certified, helping to improve multi-vendor capability between devices. DALI systems require substantially less wiring than traditional lighting system, meaning less work and lower cost. DALI wiring costs less and is more robust. DALI enables the creation of multiple groups, meaning users can control a light luminary, a whole room or entire room. Friends, lighting control provides flexibility. With a comprehensive lighting system, you may need a little more than a light switch to control them all, especially if you are using smart options with sensors and automatic responses. Many modern systems can work wirelessly, which is especially beneficial for retrofitting or for buildings with hard to wire areas. Wireless control can also be placed almost anywhere and moved or expanded as needed. One common lighting control method is to install occupancy sensor that will automatically turn on your lights when employees are present. This approach saves energy since it turns off when not in use and even offers hands-free activation. Friends, now we are discussing lighting automation requirement as per EC Energy Conservation and Sustainability Building Code 2024. Sorry, it is 2024 that outlines the requirement for lighting automation, including the use of sensors, schedule controls, and dimming system. These requirements are designed to ensure that lighting is used efficiently and effectively, contributing to energy savings and compliance with building energy codes. Uh, Let me tell you that ECSBC 2024 is applicable in all those buildings which are having a requirement of air conditioned area 1000 square meter or lighting load more than 100 kilowatt or 125 kVA. The code mandates that lighting system be capable of turning off or reducing power when not in use, which can lead to significant energy cost savings. Additionally, the code encourages the use of daylight integrated lighting and control systems to enable occupant satisfaction and productivity. The first measure is automatic lighting shut-off. Interior lighting must have an automatic control to reduce energy use. 1. In spaces larger than 300 square meter, 90% of the lighting fixture must be equipped with an automatic control device. These devices must operate in one of the two ways. One is scheduled control, pre-programmed times, or occupancy sensors that turn light off within 15 minutes after spaces become unoccupied. Fixtures controlled by sensors must also have a manual switch to turn light off when the space is occupied. Friends, The clause 7.2.2 of ECSBC uh, dictates interior lighting control system. A. Automatic lighting set-off. At least 90% of all interior lighting fixture by wattage in buildings shall be equipped with automatic control device that shall function on either a scheduled basis of a specific program time and second occupancy sensor. The schedule basis an independent program schedule shall be provided for areas up to and including 20,000, 25,000 square meter and not more than one floor. Second, occupancy sensor that, that shall turn off or dim by at least 80% of full light output. The lighting fixture within 15 minutes of space becoming unoccupied. Light fixtures controlled by occupancy sensor shall have a wall-mounted manual switch capable of turning on or off light when space is occupied. Exception to this rule is A. Lighting required for 24/7 continuous operation. B. Lighting in spaces where patient care is rendered. Hospital, healthcare systems. C. General lighting and task lighting in spaces where automatic lighting setup would endanger the safety or security of occupant in the space. B. Each space enclosed by ceiling height partitions shall have at least one control device to independently control the general lighting within the space. Each control device shall be activated either manually or by occupant or automatically by sensing an occupant. Friends, what is an occupancy sensor? Say, occupancy sensors are smart motion activated devices that automatically control lighting, HVAC, and ventilation system based on room occupancy, significantly reducing energy consumption and utility cost in residential and commercial spaces. They utilize technology like passive infrared PIR systems, ultrasonic or dual technology to detect presence, turning light on upon entry and off after a set period of inactivity. The common type of occupancy sensors suitable for ECBC, although the code does not require a specific sensor technology, the following are the commonly used building building to meet ECBC control requirement. These three types we have already stated are passive infrared, ultrasonic, and dual technology. The three. I have shown the shapes here. Friends, will discuss the characteristic feature of three different type of sensors that are suitable to ECSBC code of 2024. First one, passive infrared PIR sensors detect infrared energy, that is body heat, when someone moves in the coverage area. Widely used in general interior spaces. Best in area with clear line of sight movement. Friend, these passive PIR sensors are needed, one in 7 by 7 meter area. Ultrasonic sensors emit inaudible sound waves and detect motion by measuring the reflections. Better for rooms where people might be present but not more directly into line of sight, e.g. storage and rooms. The third technology is dual technology, which uses these both passive and ultrasonic sensors. So dual technology sensors are combining PIR plus ultrasonic detection. Second characteristic is reduce false triggers, light switching on or off incorrectly. Common choice for larger or irregular used spaces. Friends, occupancy sensors are required and are mandatory in all habitable spaces more than 30 square meter in building having total area of constructed area of 20,000 square meter. Storage or utility spaces more than 15 meter square in large buildings. Public toilets more than 25 square meter in area control at least 80% of the lighting wattage. Corridors in large hospital buildings 70 to 80% of lighting. All conference meeting rooms. So in a healthcare industry, there is a large number of corridors, and this is where we can save the energy. Third, space control. Each space includes by ceiling height partitions must have at least one lighting control device. This device may be manual switch or automatic occupancy sensor. Limits on how much area one control covers equal to or less than 250 square meter for smaller spaces, that means buildings, and less than or equal to 1000 square meter for larger spaces, which are buildings which are having built area more than 1000 square meter. Control must be accessible and visible to occupants and capable of overriding set of controls for up to 2 hours. Friends, we have already discussed daylight area control. Now we are discussing exterior lighting control. All exterior lighting must be controlled by photosensors or astronomical time switches that turn light off when daylight is available or lighting is not needed. Emergency security or required safety lighting is generally exempt. Friends, this is one of the dolly system manufactured by Philips India Limited, and this provides you convenience of providing dolly ballast at different floors and control the illumination systems through a software known as area manager. Uh, every floor must be provided with one area manager, and after that the dolly ballast. This ballast can control 9 different outputs. Okay, thank you for observing the presentations peacefully and continually.